All right. I'm going to solve this problem here. We're going to start the timer, then we're going to start reading. So we have, you're giving, let's call it custom sort string. You're giving two strings, order and S. All the characters of order are unique and were sorted in some custom order previously. Permute the characters of S so that they match the order that order was sorted. More specifically, if a character X occurs before character Y in order, then X should occur before Y in the permuted string. Return any permutation of S that satisfies this property. CBA, and then we have ABCD and CBAD. Right? ABC appear in order, so the order of ABC should be CBA, since D does not appear in order. So D can go in any order. Okay. All right. BCAFG. We have A, B, C, D. So we need to have the C. We need to have B before A and C. So we need B, C, A, D, right? And it also shows us that if it's in order, it doesn't need to be in S, right? Let me look real quick. Following the order of appearance, and A. Other arraignments like DBCA. All the characters of order are unique and were sorted in some customers. Okay, so I'm going to do this here. We're going to grab the thing. So given a string order and S, sort the string S, create a string that satisfies the order given by order, right? And we know some things. Every car in order doesn't have to exist in S, and vice versa. Right? So, if the cars in S that aren't in order can be placed anywhere in the string. In the result string. All right? Every character in order is unique. The same can't be true for S, right? Some questions I would ask. Some questions I would ask is, what is the range of, what type of letters are in order, right? Because it can be Is it just lowercase letters? Is it just is it lowercase? Is it all ASCII characters? Right. What type of letters are in order? Will order or S ever be empty? Right. Those are going to be some edge cases there. Will order or S ever be empty? All right. Order or S ever be empty? What to return? If so. Okay. So then, approaches. So I think the easiest way to do this would, given a car in order, so given a car in order, we'll iterate over order, and then for every car, we'll create a string builder. We'll iterate over every car in order. We will find that corresponding car in S, delete it somehow, and add it to a string builder. And then whatever characters are left over in S, we could just append it to the end and return that string, right? So iterate over order and find the corresponding, find the character in S, right? Iterate over order, find a character in S, push to a string builder. Append remaining characters, right? Iterate over order, find characters. It's going to be, so it's going to be O, that's going to give us like O of order times S solution. And our space is going to be S, right? It's going to be O of S, right? Because we're going to return the a string. We're going to return a string the same size as S, right? So we're going to put time here. So time, so O of order of S, space is going to be O of S because we need to, space is O of S. So given that we, iterate over, given that we iterate over S multiple times, we can probably see if there's a way to reduce that. So I think we could do a frequency count. Frequency count of the characters in S. Put in a hash map. Iterate over order. Create a string builder. So put in a hash map. Create a string builder. Create a string builder. Iterate over order. When we find a character in the frequency count, we append that many to the result string and remove from hash table. At the end, we iterate over hash table. Iterate over hash table and add any leftover letters, right? All right. And iterate over hash table and add any leftover letters. That looks like it'll work. That's going to give us a time. That's going to be a. So first it's going to be a S. It's going to be S plus order, right? And then what our space is going to be. So we're going to have a hash table. In the worst case, every character in S is a unique character as well. So our space complexity would be on average O of S as well. And that's probably the best case scenario we can get, because we've eliminated having to iterate over S multiple times, and we still only iterate over order once. There may be a way to, I think we always have to go over every character, at least in order, just in case, right? So that's probably our best case solution there, and we're probably going to code that up. Let me see. So our tests, so our inputs are CBA, ABCD, CD, and let's copy and paste this here. Put order S is here, and input order. Let's call this GPX, and then we have AG age we have this random, right? And then our output here, this is going to look like B, C, A, D, right? And here, our output is going to look like C. Output is going to look like CBA, D. Right, and our output here would be GG, PP, X, AEE. Right? So I think, we can go on and code this up, and then we will do a little dry run. So first we're going to create a hash map, character, integer, frequency count is equal to new hash map. We're going to do a string builder. And the result is equal to new string builder. All right, it's going to be our string builder here. And then for car C N S dot to car array. All right, we're going to do frequency count dot merge, and that's going to be C1 integer sum, I believe, something like that, right? And that's just an easy way to generate frequency count in a hash map. Sorry, I had to update I had to open the blinds. It's getting a little weird. The lighting here is pretty bad. So now we're going to iterate. So for int I is equal to 0. No, we can just do this as well. So car C in order dot to car array as well. Car array. If frequency count dot contains key C, oops, that's X. So if frequency count contains C, we're going to grab we're going to grab it. We're going to grab it. E int equals end is equal to frequency count dot get C, and we're going to do a frequency count dot remove C, and then for int I is equal to 0, I is less than n, I plus plus. We're going to do result dot append C, right? And we'll do one more. We'll do one more right here. So then we'll do for entry character integer E and frequency count dot entry set, right? So frequency count dot entry set. We're gonna do car C is equal to E dot get key, and int n is equal to E dot get value. And we're gonna do this here as well. So we're gonna do this again, right? And that tells us that we need to put this in some sort of function. Right. Then we're going to return result.toString. All right. And let's use, okay. So now let's run this. So we're going to use our input. So we'll do this here. Right. So we're going to count it here. So we're going to create our hash map. We're going to result our string builder. So here, all right. Now we're going to iterate over the array. So for here, let's put our map. So our map is going to look like, so frequency count is going to look like here. So let's use BCFG, right? So it's going to be we're going to use we're using ABCD. So A1, we'll do a key value pair like this. A1, B1, C1, D1, right? So that's going to be our frequency count. Result is still an empty string here. So now we're going to iterate over order, right? So order is going to look like, so here, what are we going to do? We're going to copy this here, put this here. So now we're going to be going through order, right? So order, sorry, I'll put this over here. Order is BCFG, BCAFG. Our output should be BCAD, right? So after this one, we're going to do what? We're going to, so result, C, Lord have mercy, my fingers. C is equal to, B, C. We're going to do all of this one here. C is equal to C. C is equal to A. C is equal to F. C is equal to G. And what we're going to do is, for every one of these iterations, we're going to check to see what our frequency count is. All right, so C is equal to B. Since B does exist, right? So B does exist. We have our frequency count here. Since C is equal to B, we're going to append it here, and we're going to remove it. So now our hash map looks like this, and our result string looks like this. And then we're going to, right? So C is equal to C. C does exist. We're going to add it to our result string, and we're going to remove it from our frequency count. Right? Here. Does A exist in our hash map? It surely does. So A is going to end up here. Frequency of BCA. Right? Here. Nothing happens because there is no F. Here, nothing happens because there is no G. Right? So right now, our frequency count is just a single thing. So we're going to now iterate over the entry set. So we're going here with it. I'm going to go here with it. So here, our only entry is going to be D1. So C is going to equal to D, which is the key. And then N is going to equal to 1, which is 1. And then it's going to iterate from 0. And once it becomes 1, it's going to be a thing. Our result is going to equal BCAD. And then we're going to return it. Boom. And that should be it. Son of a bitch. Son of a bitch. There we go. 22 minutes and 49 seconds, which is pretty much on point where I need to be if you want to solve 2 questions in 45 minutes. This is really good, and I think I did a good explanation. Thank you. I forgot how to stop recording on this thing. How do you stop?